Hi everyone, welcome back to my channel. Myself Rama, SDM College, Phenols. In this session, we are going to discuss about ethers. In the last session, we have discussed about alcohols and phenols, the nomenclature of alcohols, nomenclature of phenols, and the preparation methods and the uses. So these part we already studied. Correct? In this session, we are going to discuss about ethers. First, as usual things, the types of ethers, or better to call it the classification of ethers, and the nomenclature of ethers, preparation, properties, and uses. So these parts include under ethers. First of all, what is ether? Ether is nothing but, so it is generally denoted as ROR dash. Ethers are represented as ROR dash. So this is the functional, or it is the general formula of the ether or functional group. In this case, what do you mean by alcohol, or what is the general formula of alcohol? Yes, it is ROH. Here, hydrogen is attached to oxygen, and in case of ethers, another alkyl group is attached to oxygen. That is the difference. So this is also belongs to the family of the alcohols. In case of phenol, R is replaced by AR, or aromatic groups is attached. Our aromatic group contains OH, hydroxy group. Aliphatic group contains hydroxy group. In this case, alkoxy. Okay, what is ether? Alkoxy alkyl or alkane. Okay, alkoxy alkane. It is hydroxy alkane. Hydroxy aromatic phenol. Okay, so ethers means it is alkoxy. In this case, there is a difference things we observe, and there are two important classifications of ether. Depends upon the nature of alkyl or R group that is attached to R group. Depending upon this R dash, the ethers are classified into two. The two important classifications of ethers are classification of ether is, one is simple or symmetrical. Simple or symmetrical ether. Second type of ether is symmetrical, another is asymmetrical ether. Asymmetrical ethers. So ethers are classified into two. One is symmetrical ether and another one is asymmetrical ether. As the name indicate that the type of ether. So it is completely depends upon the alkyl group attached. And consider one example same as this based on this functional or general formula. I am consider one example. Methyl group is considered in place of R, methyl, O, again methyl. Okay, in this case, what happened? Methyl. Okay, R and R dash, both R and R dash is same. So both the side we observe the same type of alkyl group. Therefore, it becomes symmetrical. Adjacent side, on the adjacent side of the oxygen, or both the side of the oxygen, same type of R group is substituted. Hence, it becomes symmetrical ether. Okay, therefore, what do you mean by by the symmetrical ether or simple ether. Simple ether or symmetrical ether is nothing but the same type of alkyl groups are attached or attached on adjacent side of the oxygen. Then it becomes symmetrical. The general formula of the symmetrical ether is ROR. Okay, ROR. Correct? Because R dash is a similar that of R. Next example for this type of ether is this one. Example is CH3O CH3. Next example is C2H5O C2H5. Okay, so what type of alkyl group you are consider in the first case? The same type of alkyl group is attached on the another side. Another example, you can take any alkyl group, okay, on the other side of the oxygen. Then it is considered as a symmetrical or simple ethers. Next type is asymmetrical ether. What do you mean by asymmetrical ether? Asymmetrical ether, in this case also, name indicate asymmetrical. There is no symmetry around the oxygen of the ether. Therefore, the general formula becomes R O R dash. R is not equal to R dash. Here, correct? Next example for this case is example for asymmetrical ether is CH3 one side CH3 methyl group is substituted and another side C2H5 different group is substituted. Correct? Okay, we can take another one C2H5O C3 or better we can C4 also. There is a possibility, or you can take it as C4H9. Okay, so these are the different. In this case, here oxygen attached to different type of R group, oxygen attached to different type of R group. Therefore, these are asymmetrical. Around the oxygen, you can't observe any symmetry. Okay, so this is the another type of ether. Then the doubt is arises. Suppose any aromatic would be substituted to the oxygen, then what type of ether? Yes, in the aromatic case also we observe these two type of classification. Okay, and consider one small example. Benzene or aromatic ring. One R group is aromatic, okay, aromatic, and another side CH3, aliphatic, aromatic, AR, O, R. This is the example for aromatic type of ethers. Then what type of ether is compared to these two? Or based on the classification, this is asymmetrical. Around the oxygen, we observe the different type of alkyl or aromatic. Suppose in this case, and both the side, aromatic group is substituted or then that become symmetrical ethers. Okay, aromatic, symmetrical, aromatic, asymmetrical. So whatever we observe in the aliphatic, similar type of classification we observe in the aromatic also. Okay, this is the classification of ether. Okay, there is easiest part we observe in this case classification. But in case of alcohols and ethers, there is a large part we observe under classification. Next. Based on the symmetrical and asymmetrical ethers, the naming of ether will be The naming of the ethers is known as nomenclature. Nomenclature of ethers. Okay, naming of ethers. This part is a little bit important compared to your exam, or in case of your competitive exams also. This part is important. Nomenclature of ethers. How this nomenclature is made on ethers? The things under nomenclature is, we should remember the nature of the ethers. Okay, the nature is, or type is symmetrical. One is symmetrical type of ether, another one is asymmetrical type of ether. Then next, what are the important things we should remember during the nomenclature? There are two types of nomenclature. One is common naming system and another one is IUPAC nomenclature. Okay, both type of naming is important in case of ethers. If the ether is symmetrical, then how to name the ethers? Okay, there are two ways we observe under common naming system. It is completely depend upon the types of the ether. Okay, please give the concentration for this part. I am considered symmetrical. Symmetrical is represented as R-O, R dash, correct? Okay, symmetrical, around the oxygen, symmetrical. Next thing is the common naming. Under the common naming, we observe a general naming system. That is, if it is symmetrical, we should use di. The prefix di is used in case of symmetrical during the common naming system. Okay, it is an important thing. What is the important thing? In the under common naming system, symmetrical ethers are prefixed as di. Next, di-alkyl. What type of alkyl group is attached? Based on that, alkyl, di-alkyl. What type of compounds? These are ethers. Di-alkyl ether. Okay, this is the common or general method of naming the ether. Di-alkyl ethers. Di-alkyl ether is the general way of common naming system. And what is the IUPAC system? In case of IUPAC naming system, the symmetrical ethers are named as same R1. It is named as alkyl. Sorry, it is named as. Here we observe one thing. There is an oxygen at the center. We should consider one part. Okay, one part. It become one part become alkyl. Another part become alkoxy. Okay, please remember, any alkyl group contains oxygen. Alkoxy. Correct. This type of naming you are already made in your first year part. Alkoxy. Okay. In case of IUPAC naming system, alkoxy is used. Alkoxy first. Next, the other part is alkane. Alkoxy alkane. Okay, this is the general way of naming the ethers. Under common naming system, di-alkyl ether. Under IUPAC system, alkoxy alkane. Okay, let us discuss the naming of, or by considering the different example, we will discuss about the symmetrical ethers under these two categories. First, I consider simple example CH3O CH3. Okay, one carbon atom is attached to the oxygen. In this case, this is the first member of ether. The other common naming system, it is named as in the form of dialkyl ether. What type of alkyl group? What type of alkyl group? Alkyl group is methyl. Methyl, correct? Here also methyl. Methyl, methyl. Therefore, dimethyl. Okay. Next is dimethyl. This is methane. Sorry, methyl. It is ether. Okay. Dimethyl ether is the common name of the ether. Next is alkoxy. Alkane is the type of it is the way of IUPAC system naming the symmetrical ether. The symmetrical alkoxy. One part is considered alkoxy. You can consider this also. This part or this part. Alkoxy. Alkyl group is methyl. Therefore, it is methoxy. Here, one carbon atom. Then it is methane. Correct? Methoxy, methane. It is the IUPAC system naming the symmetrical ether. Next one, consider the higher number C2H pi O C2H5. What is the common name of this compound? Common name is, in the both side we observe ethyl group. Two ethyl, therefore ether. Very easy. Okay, diethyl ether. Next, consider one part contains oxygen. Methoxy. Sorry, it is two carbon. Ethoxy ethane. Why it is ethane? Yes, it contains sugar. There is no gap between these two. Okay, there is no gap. So it is a one word. Ethoxy ethane. Okay, this is the way of symmetrical way of naming the symmetrical ether. Okay, next we move on to the asymmetrical ether. If asymmetrical ethers are there, then there is a small twist we observe. Asymmetrical ether. In case of asymmetrical ether, the way of nomenclature is under common naming system. So one type, and another one is IUPAC system. Okay. And consider the asymmetrical ether. Asymmetrical ether is represented as R O R dash. What is the meaning? Two different alkyl. Therefore, this one is completely different from this one. Therefore, we can't use di. Here we don't use di for the common naming system. Then it is one is alkyl group, another is also alkyl ether. Okay, alkyl ether. And in case of IUPAC system, this asymmetrical ethers are named as alkoxy. Same. Okay, alkoxy, alkane. So there is no difference during the naming of asymmetrical ether under IUPAC system. There is no difference, alkoxy, alkane. But what is the important thing we should remember here? The important thing is how many number of carbons are there on the adjacent side of the oxygen. The lesser number of carbon alkyl group or alkyl group contains less number of carbon is named first, or alkyl group contains less number of carbon. In this case, also same. Okay, less number of carbon. Less number of carbon. Okay, let us discuss the naming by considering different example. Okay, and consider one asymmetrical ether. This one CH3C2H5. Okay, CH3OC2H5. CH3OC2H5. Here one side there is alkyl group. That alkyl group contains one carbon. Therefore, it is methyl. Another side is ethyl. Okay, one side methyl group, another side is ethyl. Therefore, it is asymmetrical. Correct. Okay, next is, what is the way of common naming of this compound? Methyl, alkyl group, methyl, ethyl, ether. Methyl, ethyl, ether. Okay, or ethyl, ethyl, ether. There is no importance about these alkyl groups during the common naming system, but important in IUPAC system. The importance we should give the number of carbon atom present on adjacent side of the oxygen. Okay, here if you consider one part, this part, okay, only this much part, then it becomes methoxy, and another side, if you consider this one, it becomes ethoxy. Okay, then the confusion arises. Which part we should consider for the naming? Correct? Here, or during the IUPAC system, we should consider the oxygen attached to lesser number of carbon is alkoxy. Always. Okay, lesser number of carbon atom is or part is become alkoxy. This is the very important part, and this is the important principle of naming the ether. Okay, alkoxy. Alkoxy part should contain lesser number of carbon compared to the other part of the ether. Then what is the way of naming of this compound? Then it becomes easy. Now here one side is methoxy, contains one carbon, another side ethoxy. Ethoxy contains two carbon, therefore it is not considered as an alkoxy part, therefore it becomes methoxy. Okay, alkoxy part is methoxy. Methoxy. What is the other part? It is ethane, single bonded carbon atoms you observe, therefore it is ethane. Methoxy. Ethane is the name of the compound. Okay, and consider another one. C2H5, or better to consider bigger part on the left side. Okay, CH3, CH2, CH2, OC2H5. Okay, what is the name of this compound? Here, three carbons we observed on the one side, and another side is two carbon. So this one is ethyl part, this one is propyl part. Okay, one part contains three, another part contains two. Therefore, what is the IUPAC name of the compound? IUPAC name of the compound is, we should consider alkoxy part should contain lesser number of carbon. Ethyl part contains lesser number, therefore it becomes ethoxy. Ethoxy. How many carbons on another side? Three carbon. Three carbon singly bonded, therefore it becomes, yes, propane. Okay, ethoxy propane is the IUPAC name. Please practice more and more example to become part. Okay, there is no other way to remember the naming of this ether. Please practice more and more by considering different example, not the same example. Okay. Next, we move on to the aromatic. If the ether is aromatic, then I am considering one example, C6H5OCH3. Okay, this compound can be written in another way, that is this one, C6H5OCH3. This one also expressed in another way. OME. OME means, what is OME? ME means methyl. Okay, methoxybenzene. This one is methoxybenzene. What is the common name of the compound? Yes, this contains phenyl. Phenyl group it is. Phenyl, methyl, methyl ether. Phenyl, methyl ether. What is the IUPAC name? Here or during the IUPAC system, we should consider the smallest part is the methoxy. Correct? Sorry, smallest part is the alkoxy. Alkoxy is the smallest part. Therefore, this is the smallest part. This is the smallest part. This is the smallest part. Because it contains one carbon, it contains 6 carbon. So one carbon compound is small part. Therefore, it becomes the alkoxy part. It is one carbon. Therefore, it is methoxy. Methoxy. Another side is benzene. Methoxybenzene. Methoxybenzene is the IUPAC name of the compound. But very important thing is this compound commonly known as anisole. Okay, anisole is commonly known as anisole. Very important. Okay, please remember the common name of the compound anisole. Anisole is nothing but methoxybenzene. Okay, anisole is nothing but methoxybenzene. Okay, it is represented as benzene ring OME. Next, suppose it contains C2H5. C2H5. It is ethoxy. Therefore, it is represented OET. ET stands for ethoxy. Okay, ethoxy. Then, what is the name of the? What is the common name of the compound? Common name is phenyl. Phenyl. Why it is phenyl? Benzene ring. Okay, attached to oxygen. Phenyl, ethyl, ether. Okay. Phenyl, ethyl, ether, and IUPAC name is smallest part is this part is smallest. Therefore, it is named as ethoxybenzene. Ethoxybenzene. Okay, ethoxybenzene. Okay, and next one small example. Okay, I will complete this session by considering this example. C6H5. Suppose another side contains more number of carbon. More number of carbon means more than 6 carbon. Okay, remember that, more than 6. Okay, then it becomes 7. Consider 7. C7. Then how much hydrogen? 15. Correct? C7, 15. C7H15. Then what is the name of the compound? What is the name of the compound? The name is, this is the bigger part, hept. Therefore, first is heptile. Heptile. This one is the smallest part. Phenyl. Heptile, phenyl, ether. Okay. Please remember this. In this case, alkyl, ether. In case of alkyl, ether, during the common name system, alkyl contains more number of carbons. More suitable. Heptile, phenyl ether. During the IUPAC system, Phenyl, what is the smallest part? Phenyl become first phenoxy. Okay, phenoxy. Phenoxy heptane. Phenoxyheptane is the IUPAC name of this compound. Okay, please remember these names and very important part. These are the very important part. Please practice by considering more number of examples. The next session we will discuss about the preparation of ethers. Okay, thank you.